Hello everyone, I am Abir bin Rahman Bhuiya from School of Computing of Universiti Teknologi, Malaysia. Today I am here because of one of my project. I am going to talk about the linear optimization in brief. So please watch the video to know about the linear optimization. I have done a project and the optimization is based on that project.
Now I am going to talk about optimization. In a very easy way, we can say that optimization refers to three basic things, which are decision variables, objection function, and constraints. Here, decision variables are the independent variables and objection functions are the dependent variables along with the constraints, which refers to the values that need to be satisfied for maximization or minimization of any object function. There are two different types of optimization. One is nonlinear optimization and the other one is linear optimization. Now I am going to give a brief description about these two optimization. So nonlinear optimization is also known as NLP, which is the way of achieving the optimization problem where few of the constraints or objection functions are nonlinear. In short, nonlinear optimization tend to deal with that kind of mathematical optimization which is not linear. Nonlinear optimization always includes at least one nonlinear function which can be constraints or the object function. Now we are going to talk about linear optimization. Linear optimization, which is also known as linear programming or LP, is the process to find out the best outcome from any mathematical structures which contains linear relationships. For example, linear programming will find out the maximum profit or lowest cost as a best outcome from any mathematical model. This best technique is really suitable for linear models. In addition, the programming of linear programming does not refer to the real programming algorithm or methodology. Linear programming was introduced before the invention of computers in 1940s to do the old-fashioned explanation of planning. In my case study, I am supposed to use linear optimization to find out the optimal solution by using Microsoft Excel. There are few steps to find out the linear optimization, and they are the decision variables, object function, and constraints. In this video, I am going to show how I found out the linear optimization by using Microsoft Excel. Now I am going to show the linear optimization I have done in my project. So here I have taken the values, the passenger car sales and the luxury car sales. X refers to the passenger car sales and Y refers to the luxury car sales. Here I have constraints C1 to C11 and I have the equations. I find out the equations from these values. This is the volume of the whole cars sold since 2009 to 2019 in Malaysia. So I have taken these values from the given data of my project, and now I'm going to find out the linear optimization. For the linear optimization, I have already found out the coordinates from C1 to C11 by using this equation. First I have let that x is equals to 0, and then I find out the y coordinates from the equation, and then I have taken that y is equals to 0, and then I find out the x coordinates from this equation. In this way, I found out the coordinates for C1 to C11 so that I can make the graph easily. Now, for the linear organization, I need to do in this way. I need to select the C1, and then I need to insert the scatter plot and then find out the scatter. Like this, I can choose like this. Yes. So now I need to move this for my work. Okay, So now I need to edit here, select data, and then I need to press edit. So series name I will provide C1, and then the X values of the C1, and then the Y values of C2, and then I need to press OK. Then we can see the C1 line here pops up, and then we need to add it these 10 other lines. So I need to add C2, and then C2 and series X values for the X values, and for the Y values. Here I can see C2, this is also pops up. We need to add the whole like this way. So now I will again click add, then this will C3, and the X values is this, and the Y values is this, and then again we need to add C4, and the X values are this, and the Y values are this, C4, and then again we need to add C5, the X values are this, and the Y values are this. Okay, so again we need to add C6, the X values are this, and the Y values are this. Okay, and then again we need to add, I have so many data that I need to add so many times. Say 7 is this, and the Y is this. So again C8, so C8, and the X values is this, and the Y values is this. Okay, so again add C9, the X values are this, and the Y values are this. Okay, just two left. C10, the X values are this, and the Y values are this. Okay, so C11, if I want to find out, the X values are this, and the Y values are this. Okay, so I have done. So here we can see, if I make this a little bit bigger, we can see easily everything. Okay, so here we can see this is the x-axis and this is the y-axis. We can see all the lines C1, C2 until C11. There, here we can see the marks, the lines are here already marked, and we can see the coordinates from here, like here 55, and then 60, 70, 50, and we can see the intersection lines between here. This is the intersection lines. We also can see the corner lines like this we can see. So this way we can find out the linear optimization. I have found two other linear optimizations for my project. This is this is in between Peridua and Proton, two passenger cursors, and the linear optimization comes out here. The y-axis, we can see the linear lines here and the corner points and also the intersection points here in between. And one other thing I have done, the linear optimization, this is the part 3 from my project. This is the luxury cursors, the Mercedes-Benz and the BMW. This is the rate and this is the ratio, and I have found out the equation also and the coordinates, and then I found out all the values here. So this is all about linear optimization. In this way we can find out linear optimization very easily. After finding out the linear optimization from the Microsoft Excel, we can find out few more things. The feasible solution, we can here use the feasible solution to find out the feasible region. We can see that we use the graph to for the feasible solution we use like this way. And then the corner points here, the corner points we can find out from the crossing point of x1 and the crossing point of x2. We can find out like this way in the corner point, and then we can find out the crossing point here, and then the crossing point here and here. So the corner points actually occurs at the crossing points of the two constraints. And then we can also find out the optimal solution. The optimal solution is here, is given. How to find out? This is the axis and this is the axis. And then we can see the object function f is an equation to be either minimized or maximized over the set of feasible alternatives. And then we can find out the solution. This slide is given by my lecturer from School of Computing, Universiti Teknologi, Malaysia. So we studied like this way. So we can find the optimal solution, corner points and the intersection points and the feasible solution from this way.
Thanks a lot everyone for watching my video. Please stay with me to learn about new things from my faculty and from my projects. Thank you.